Hi guys, today we will be discussing annuities. Annuities is a series of equal payments or receipts for a specific number of years which are occurring at equal duration from one another. Annuities can be divided into two categories: ordinary annuities and annuity dues. In case of the ordinary annuities, payments or receipts occur at the end of each period, while in case of annuity due, payments or receipts occur at the beginning of each period. The practical examples in which we use annuities concept is student loan payments, car loan payments, insurance premiums, mortgage payments, retirement savings. All these are examples of annuities. Here we have an example on timeline. In this case, we have three equal installments of $100 which are occurring at the end of each period. So that's why it is an example of ordinary annuity. Here on this slide, we have an example of annuity due. Here we have three equal payments of $100 at the beginning of each month. Just because of the reason that payments are occurring at the beginning of each period, that's why this represents annuity due. While calculating future value of annuity, we have to use this formula. Here the amount of installment in each case is represented by R, which occurs at the end of each period. So we have n installments which are equidistant from one another, and they are occurring at the end of each period. So while calculating future value of this annuity, we have to calculate the worth of these cash flow streams at the end of n period. So how can we calculate the future value of this annuity? That is by calculating future value of each installment at nth period and then summing of those. So future value of annuity is equal to R into 1 plus I whole to the power n minus 1. This n minus 1 is represented here just because we have to make this payment at the end of period number 1, where we are desirable to calculate its future value at the end of n period. So that's why it has been compounded for n minus 1. Here we have an example of ordinary annuity which has three equal installment of $1,000 in each case. So the future value of this $1,000 at the end of period number 3 is calculated as 1,145, while the future value of this second installment is 1,070 by compounding it for a period, and the third installment will remain at its own place. So the future value of this annuity will be sum of all these three, which is $3,215. The future value of an annuity can be viewed as occurring at the end of the last cash flow period, whereas the future value of an annuity due can be viewed as occurring at the beginning of each period. We can calculate future value of annuity with the help of table also. The future value of annuity is so simple to calculate, that is by multiplying installment R into future value interest factor of annuity, which can be achieved from table number 3 of your appendix. This annuity factor can be found in the same fashion for I interest rate in n periods. So here in this case, we have to find future value interest factor of 7% column in 3 periods row, which is 3.215. So multiplying it with installment, it gives us the same value as we were having on the previous slide. Here we have an example of annuity due. Here R is the installment of this annuity which occurs at the beginning of period number 1, at the beginning of period number 2. So here all the R installments are occurring at the beginning of each period, and that's why we calculate future value of annuity due with the help of this formula, that is by calculating the future values of these installments at the end of n period. So it can be represented by this formula. Here we have an example of 3 periods annuity due, which is representing $1,000 for each installment. So we will calculate future value of all these three installments at the end of period number 4. Here this amount is to be compounded for 3 periods, this one for 2 and this one for 1 period. So, and then by summing of the future values of these installments will give us the future value of annuity due, which is 3440 in this case. It can be achieved with the help of the table, as if you are desirable to calculate future value of annuity due with the help of the factors table, you can use this formula R into future value interest factor of annuity into 1 plus I. This is 1 plus I is for annuity due factor. So here in this example, R was having value of 1000 US dollars while the factor was to be calculated for 7% in 3 periods, which was 3.215. We will multiply this with 1.07. So it will give us the future value of annuity due 3440, which is exactly the same with the previous slide. Here we have an ordinary annuity for n periods having R installment in each case. So now we can calculate present value of annuity as well, which is desirable in some of the cases. So how we can calculate present value of ordinary annuity? By calculating present values of each these installment at the period 0, at the beginning of period 1. So future present value of ordinary annuity is actually the sum of the present values of all installments. Here we have an example. We have an ordinary annuity of 3 periods having 1000 installment in each case. If the discount rate is 7%, we will calculate present value of these three amounts at the period 0. So these are the present values of these three installments, and that's why the present value of this ordinary annuity is 2624 in this case. This value can be also calculated with the help of the tables also. The present value of an ordinary annuity can be viewed as occurring at the beginning of the first cash flow, whereas the present value of annuity due can be viewed as occurring at the end of the first cash flow period. Present value of annuity can be calculated by multiplying each installment R with the factor, and that factor in this case is present value interest factor of annuity, and this is represented by table number 4 of your book. The present value of due can be calculated in the same fashion with the help of timeline also. I will recommend you people to always go for timeline for solving such type of problems. Here we have R installments at the beginning of each period. So the present value of annuity due is actually the sum of the present values of these installments at the period 0. Here we have 3 periods annuity, that is 1000, 1000 and 1000. All the 3 installments are occurring at the beginning of each period. So the present value of this installment will be its own value, that is 1000, because it is occurring at the period 0, while the present value of the second installment in this case is 934.58, while keeping 7% discount rate in mind, and the present value of the third installment is 873 in this case. If we sum up all these present values, we will get present value of annuity due, which is 2808 in this case. And the same fashion we can go for with the help of table also for the same problem. R present value interest factor of annuity into 1 plus I. So 1000 into factor into 1.07 in this case, which is the same value as we were having with the manual calculation. We can solve different complicated problems involving time value concept with the help of this. First of all, you have to follow step number 1, which is read your problem thoroughly again and again. Determine whether it is a present value or future value problem, and then you have to draw a timeline. Timeline makes these problems always so simple. Put cash flows in and arrows on timeline at the proper times. Determine if the solution involves a single cash flow or it is an annuity stream, or sometimes it could be mixed of these two. Then solve your problem. and you can check that with the help of financial calculator, or can check it with the help of tables factors. Here we have a max problem. Julie Miller will receive the set of cash flows below. What is the present value at a discount rate? Here we have this timeline. She is receiving $600 at the end of period number 1 and 2, and she is receiving $400 in the next 3 months at the end of each month, and you are asked to calculate its present value. So solve your problem in pieces at time and then group these cash flows. Here in this case, you have to calculate present values of each these factors manually. These are the present values. Some of these, this is present value of this stream, but it could be sometime complicated. If you are having a large number of cash flow, then you have to go for annuity due formulas. So you can treat the same problem in this fashion, that is by dividing into two annuities. This 600, this represent one ordinary annuity, and 400, this represent another ordinary annuity. So it can be resolved with the help of two annuities and then summing of those present values. So you can solve your max problems by following these steps. Thank you.